Alright, today we're going to talk about monomials and multiplying monomials. Before we begin, I want to go over a few concepts from last year that we might want to revisit. The first one has to do with writing in expanded form. And all that really means is when we have an expression, say for example 3 to the 4th power times a cubed, if we were to write this in expanded form, we would write 3 times 3 times 3 times 3, accounting for the 4 in the exponent, and that would also then be multiplied times a times a times a. So if I ever ask you to write something in expanded form, this is simply all that I'm asking you to do, is to write it out without the exponents. Let's take a look at another one, okay, and you can work along with me. If I had negative 11x times y to the third power times z to the second power, well, do it along with me. What do you think that it's going to look like? Well, the first factor is the coefficient negative 11, so you're going to take your negative 11, and then you're going to multiply it by the next factor, which is x. There's no exponent, so it's simply x. The next one is going to be y to the third power, so that's y times y times y. And finally, you have z squared, and that would be z times z. So if you see the directions at all about writing something in expanded form, this is simply all that we're talking about. Now if you have a group of numbers that you're working with, say for example two expressions that you want to multiply, say you have 3 times x squared times y to the second power as well. Let's do that. And then we're going to multiply it times 4x and then y cubed. All right, now you've got a lot of stuff going on here, but you've got a lot of things that you can work with very easily. Look at your two coefficients, and because of the rules of the associative property and the commutative property, we know that we can pull this out. Order doesn't matter, grouping doesn't matter when we're dealing with multiplication. So we're going to take the 3 and multiply it by the 4. So pull those two out and deal with them. Then find the two that are the same in the next group. So you've got an x squared times x. And then finally, you've got y squared times y cubed. So that's a y squared times y cubed. And this now has kind of broken out what we're dealing with, and you're looking back at the way things were written in expanded form. All right, let's continue on here and break this down even further still. If you recall, when we were dealing with exponents last year, we talked about taking those exponents, say for example the y cubed or y squared times y cubed. Well, when we're dealing with variables and exponents, all we have to do, and as long as the bases are the same, that's the critical thing here, the bases need to remain the same, you take your y and then all you do is add the exponents. So we take 2 plus 3, and that yields y to the 5th power. So when we are multiplying with exponents, we add the exponents. And if you recall, when we are dividing using exponents, we subtract. So it would be y to the third power divided by y to the second power would then give us simply y, because you're subtracting the exponents. Now let's talk about why this actually works. Well, if we go back to our thought process with expanded form, you would see that in the first case, this one here, you're talking about y times y times y times y times y. Okay? Y to the second power, y times y. Y to the third power, y times y times y. Well, what did we end up with? We ended up with y to the 5th power. So that's why adding the exponents work when you're multiplying. Now let's take a look at the division and see why that works. Well, you've got y to the 3rd power over y squared. So y to the 3rd power over y squared. Well, if I write that out in an expanded form, I've got y times y times y over y times y. Well, these guys cancel each other out, these guys cancel each other out, and I'm simply left with y. So if we recall the way that we dealt with exponents when we were when we were multiplying, and we recall the way that we were dealing with exponents when we were dividing, it helps us to simplify these monomials. So let's take a look at another one. Work along with me. Let's take something a little bit more complicated. Let's take 6 times a cubed b to the 4th, and we're going to multiply that guy by 2 times a squared b to the 5th. So again, separate out your common factors. You've got the 6 and the 2. You've got the a cubed and the a squared. And then finally you've got the b to the 4th times b to the 5th. And here we go again. All we're going to do, this becomes 12. We take this factor, this variable, and we add the exponents. So 3 and 2 is 5. And we take this variable and we add their exponents, and 4 and 5 is 9. So to take this and simplify it, that's what you end up with. So again, just break things down, take what you're working with and think about each component, break them out if you need to. If you want to write it in an expanded form because it makes it easier, you can do that still. But these are the concepts that we're going to be dealing with when we're talking about monomials. And I hope you found this helpful.